All right, so good evening, everybody. Let's jump right into it. It's an extra session, so we're not doing too much. I already have the document pulled up on the screen for you. So we're gonna go ahead and please feel free to um ask questions, verify, do anything, do over anything that seems unfamiliar. Do that. Please don't do the please do not write your solutions in your regular notebook. If you can get some folder leaves that is separate, we're just gonna call this practice session. All right. So we don't want it mixed up with the regular notes. That's what I would prefer. All right. All right. So let's go here. All right. So there we have it. Oh, sorry. I'm gonna refresh this screen. All right, so guys, you can see it here on screen. It's a small little workshop paper that I put together, right? And it covers about 6 topics, ranging from fundamentals to a bit of algebra to a couple of worded questions that is very familiar. And if you scroll down here, you'll see also a little bit of geometry. That's a topic that's coming up. We may or may not do it in this class. And we have something about volume, which is something that's coming up. And then we have something about the circle and also the coordinate geometry, gradient and length. So what I'm going to do, guys, is it's a lot easier. Let's say for hypothetically that we don't get to finish the paper today. I feel like it's easier for you guys to do number one. So I won't want to spend time working number one when I know that you guys could figure it out. I want to attack the worksheet from the back around here. That's what I want to work out. All right. So these questions are more challenging and requires more critical thinking. All right. So if you guys are okay with that, you can go ahead and proceed. Everybody comfortable with that?
Yes, sir.
Yes, sir.
All right. So we're gonna start at question number 6. Right. And in question number 6, um, question number 6, we're talking about a circle. And let's continue. Let's see. So it says a circle with center O and a radius of 6 centimeters. Your job is to calculate the area of the sector with an angle of 120. You are to determine the length of the major arc, and you're also to calculate the circumference of the circle. All right. So it's just a quick little revision. It's just like, as I said, this session, guys, is practice. What we are doing now is exactly what I would have been encouraging you to do over the past 4 months. When I say practice, you take up a bunch of random questions. They're not directed specifically at anything, and you just use the notes that you have to practice. So this is what I call a practice session. All right, so first thing I want to do here is I want to go ahead and say draw my circle. All right. So when you get worded questions that you're not seeing a picture, what you want to do is create a picture behind it. So what we're looking at here is a circle. All right, that's my circle. And what you're seeing here is that the circle has a center, which is right there. I've dotted it in black. I'm going to draw a line from here to the circumference. Oops, don't like how that look. All right, good. So let me see if I can zoom it up better. All right, so that's my circle. All right, I'm going to go back to the notes first. So that's my circle. And I'm going to put the circle, I'm going to have a center right here. That's the center. And from here, I'm going to draw a line like that. That's going to be my radius. All right. And you're seeing that the radius is, I believe it says, what, 6 centimeter? 6 centimeter. All right. All right. Now, the circle is always labeled with the center O. So that's the only information they gave us. They say that we are to, let me see here. They say that we are to calculate the area of the sector with an angle of 120. Now, at the present moment, you're not seeing a sector, right? So you are going to have to be the one to create the sector. Now, for you to create a sector, you have to have another radius, right? So I want to have another radius like so, like this, right? So I want to do it like that. And then right here is where I'm going to put the 120. So as you would have known in class, we discussed this. The sector is a region, or it's a slice of pizza. It's a region of the circle that is created by two chords, by two radius, pardon me. So basically, I've drawn one radius. So for me to create the sector, I have to draw another radius for the sector to be constructed. So what I'm looking for now is this area inside here. Let me just shade it with blue, so with purple. So what I'm looking for is the area of this particular shape, this thing here that is in purple. Now, in our class, we would have learned that there's a formula for sector. And if you can grab your notes, you'll remember when I told you that ASEC is equal to 3 angle divided by 360 multiplied by pi r squared. That's the formula for finding the area of a sector. All right? Now, so now we can go ahead then and say that the angle, because remember now we're looking for, them say that we wanted to find the area of the sector with an angle of 120. So they're basically telling you that the angle of that sector is 120. We'll then divide that by 360. And then we're going to multiply that then by the pi value, which is 3.14. And according to the question, the radius is going to be 6 squared. All right? Now, if you grab your calculator, you'll find out that 120 divided by 360 is 0.33 reoccurring. So 0.33 times 3.14 times 36, because 6 squared is 36. So go ahead and process that on your calculator for me and tell me what answer you got. And so we'd have calculated the area of the purple section. Yeah, guys, you can go ahead and tell me what the answer is. Isn't anybody working with me?
Sir, mine is taking a while to load.
Nobody yet? 3 numbers, 3.333 times 3.14 times 36. Anybody?
Sir, 37.64.
Thank you so much. 37.64 squared centimeters. And that is the area of the purple section. Okay? All right. So that takes care of that part of the problem. Let's move on then. All right. Any questions on that? No? All right. So let's put a little highlighter over here. Yeah. So this is our sector formula. All right. And like I said, good news or bad news, I don't know. It comes on the exam papers. I don't know if you want to take that as good news or bad news. But once you see the sector, the formula for the sector, you will see the formula on the exam paper. Now, moving right along to the next one, if there's no question. Determine the length of the major arc. So be careful now, guys. What you're seeing now is the major. Notice them use a keyword here, major arc. So let's go back to the diagram now and look at what is called the arc. Now, the arc, as we said, the illustration that we gave for the arc was that it's the crust of the pizza, the outside strip of the pizza. So therefore, it is the distance of the red section that you want, that curved red section. But we don't want the entire curve. What we want is, and I'm going to use black here to show you, we want this section right here, all around here, all the way around here. That's the major arc. We want all of that piece come all the way to about here. We don't want to go past that. That's the major sector. Now in class or in the last upload that I would have made on the recording, this would have been explicitly explained that when you're finding something major, you need what is called the major angle. Now, if we are familiar or we can recall that the total angle in a circle is 360 degrees. So all of this angle right around here would have been 360. We were told that the small angle is 120. So therefore, I know that arc length, so arc length, no, let me put it the other way, L arc, the length of arc, L arc, is equal to theta divided by 360, very similar to the previous one, but this time it's going to be multiplied by 2 pi r instead. So in this case, now you have to be very mindful of what you're using for theta, because theta is now going to be 360 minus 120. Sir, why? Because they said major, and what we have is the what? Minor. So if you want the major, you have to take the minor away from the complete angle to get the major. All right, so hopefully that makes sense. I think I would have gone through an example like this in class. All right, so in this case, then I know that 360 minus 120, that's going to give us 240 degrees. So therefore, this is going to be 240 divided by 360 multiplied by 2 times pi, which is 3.14, times 6, which is the radius. All right, go ahead, guys, and process that calculation for me. 240 divided by 360 times 2 times 3.14 times 6, and let me know what you have gotten.
25.12.
Just centimeter. That's it, because it's the length of the arc. All right. So hopefully you guys catch on to that. Any questions thus far? All right. If you're seeing these formula for the first time, like I said, the recording is available. You can get a more detailed breakdown of how we derived or how we got the formula and how you can identify the sector and the segment and all of that extra stuff. All right. It's all there for you to review. All right. If there's no question, let's move right along to the next one. Now they ask us to find the what? Circumference of the circle, which is a much straightforward question, right? No challenge there, because circumference is going to be equal to 2 pi r. So circumference is equal to 2 times 3.14 times radius is 6. I should have asked you this question first, you know? That would have made more sense. Right, so go ahead, guys, and process this calculation for me. What is the circumference of the circle?
Sir, 37.68.
Centimeter. Thank you so much. And that is going to be the perimeter of the perimeter of the circle. All right. All right. So that takes care of that little question there. Nice little practice, right? Nothing too much. It's not really advanced, right? But it's just a quick little reminder of how you approach these mathematical problems. Okay. Right. No questions. Let me check to see if there's anybody else who's in the waiting room. Oh, Avian is here.
Sir, can you slide that I can see the questions, please?
Sure. Avian, you were waiting for a while?
Yes, sir, about 15 minutes. Good afternoon, everyone.
And honestly, we've been here teaching, because I started at 2:05.
Good afternoon.
Good afternoon. I started at 2:05 because, as you can see on the screen, that we've gone through one question already. Should I just message them and let me know that you're in the waiting room? All right. All right. Genesis, you wanted to see the working out, you said? There it is. Avian, you can go ahead and take a screenshot of this. This is the working out. This is the only question we've done thus far. And the session is being recorded as well.
I want to see the worded.
You want to see the worded question?
Afterwards.
Okay.
Yes.
Okay, there it is. All right, we're good to go? So that question is out. All right, may I move on?
Yes, sir.
All right. Now for the next question here. Next question here. Here we go. Here it is. So for the next question, we are told that given a straight line is drawn by connecting the points A, 3, -2, and B, -1, 7. Your task is to calculate the gradient of AB using the graphical method. You are to also go ahead and calculate the length of AB. You are to also calculate the coordinates. That was supposed to be off, but we have PF, so it's supposed to be off. So calculate the coordinates of M, calculate the equation of AB, and determine the equation of the perpendicular bisector. Now, this is a topic that I did. I don't think I taught it in, well, I think for my online students, I taught it in full, right? However, I did send you a link over the Christmas break, and I said to you, hey, try to find some time to take out the notes from it because we needed to, because of the Hurricane Melissa, we had to skip over a topic so we can stay on track. So, that this whatever we are about to do now, whatever you're about to see, the complete tutorial is available. As I said, you can review it. But I'm going to run through these questions for you. Okay? All right, so first question says here, given a straight line is drawn by connecting the points A, 3, -2, and B, -1, 7, you are to calculate the gradient of AB using the graphical method. So the mere fact that it's a graphical method, it means that we're going to have to do some sort of sketch. Now, I'm going to assume that you guys don't have access to a graph paper at the moment, but if you do, you can go ahead and replicate what I'm doing. So I'm going to go ahead here. I'm going to sketch a little graph, right? That's my y-axis. And this is my x-axis, all right? And as per usual, I'm going to go ahead and number. So that's 1, 2, 3, 4, 5, 6, 7. I'm going to go ahead and number this as well. 1, 2, 3, 4, 5, 6, 7, right? Just draw this line up a little bit more, right? 7. I'm going to number down here as well, even though I may not end up down there, but I'm still numbering it. 1, 2, 3, 4, 5, 6, 7, 8. Continue. And then over here, 1, 2, 3, 4, 5, 6, 7, 8. All right? Now, hopefully we can recall that all the numbers to the right, that's all the numbers over here. Sorry. So now if you can recall that all the numbers here, all the numbers along this line here, they're positive. So from here, this is 1, that is positive 2, this is positive 3, positive 4, positive 5, positive 6, positive 7. The numbers along the y-axis here are also positive as well. So that's 1, 2, 3, 4, 5, 6, 7. When we go over this side now, the numbers are now negative. So from this first one here, which is what? -1, -2, -3, -4, -5, -6, -7, -8. And then all the way down here on this line now we have negative numbers as well. With -1, -2, -3, and so on. Okay? So for the purpose of neatness, I'm not going to write the numbers. But when you're doing it, you're supposed to what? Write the numbers along the axis here. Okay? So see if you can work with me as best as you can. So the first thing that we're supposed to do is plot this point here, 3, -2. Now 3, -2, the first number, all right, and if you can recall that the first number is x and the second number is y, all right? And then again, the first number over here is x and the second number is y. So the first number tells us what direction to move along the x-axis. And so if it's positive, we are obviously going to go, if it's positive, we're obviously going to go this direction. So look at this now. This is 3, negative 2. This is telling me that I should take 3 steps to my right and 2 steps down. So I'm going to come to the corner, right to the center here. I'm going to count 3 units. 1, 2, 3. And then I'm going to count 2 down. 1, 2. So I'm supposed to be somewhere right there. Right where you see it. Probably not accurate, but somewhere there. Okay? So I'm going to place a point right here. It's not quite exactly that, but I'm going to, let me see here. So let's see about here. About right? Not quite. Let's try again. Somewhere there. About there. All right? So that's going to be our point A. We can label that A. And then now our next point now is going to be negative 1, 7. So that's negative 1 to my left. So once again, negative 1, whoops. So negative 1. So negative 1 is going to be from here. Negative 1 is to my left. Because remember, you're always counting from here. So negative 1 to my left. And then we're going to go 7 up. 1, 2, 3, 4, 5, 6, 7. So all the way up here, somewhere here we're going to be. All right. So I'm going to place my point about here. All right. And that point is going to be called point B. Now I'm going to use a different color here just to make sure that we can distinguish between the axes. I'm going to place my point here. And that's going to be my line. That's my line AB. That is my line AB. So whenever in the future you get a question where you have to plot a point, that's how you go about it. All right. So that's going to be 3, negative 2. So let me just put some numbers on here. So this is 3. Oops. All right. So this is 3. And this is 2. This is negative 2. And this is negative 1 right here. And up here, so it's 7. All right, so we are supposed to use now the graphical method. Now, if them specify, all right, for CXC, they don't specify and tell you what to do. You can either use the formula or you can use the graphical method. But because I know that I haven't taught this in a while, or we haven't done it, I still need to ensure that you guys recall how to get this thing done. So we need to go ahead and find the graphical method. Now, hopefully you guys remember, when we're using the graphical method, we need to use something known as M equals rise over run. Rise divided by run. Now the rise is a vertical movement. So I have a choice now, guys. Watch how I go on now. I can rise from A. So watch me now, that's the rise. I can rise from A and then run towards B, or I can rise from B and run towards A. The point I'm trying to make here is that you have to create a right angle triangle around the line. So if I use this pink color here and I draw a line upwards here, it's not accurate, guys, forgive me. Oops. Let's see here. Oh, what is that? All right, so I'm going to try to see if I can do it as best as I can. If I rise from here, right, that's my rise. Good. And then now I'm going to run towards B. So run has to be horizontal. So I'm going to run towards B like that. That's my run distance. So now I need to figure out what is the distance between here and here. How tall is that line? What's the height of that line? Now, I'm going to use a cursor. Watch me now. Watch the cursor on the screen now. This point right here, ladies and gentlemen, this point right here, A, it is in line with the number -2, right? According to the plotting, it's in line with -2. So let's count all the way up until we're in line with 7. Count with me now, right here. So we're at negative 2. We're going to count by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, what that means is that between A and this distance up here, between here and here, is approximately 9 units. All right, so this here is going to be positive 9 because we're going up. Positive 9. All right, now we're going to run. Now pay attention to the run now. Now if you notice here that the run, now look at this now. I'm all the way up here now. I already know from here to here is 9, so I need to run this direction. How far is from here to here, this purple line from here to here? What's the distance? Now if you notice that this point here is in line with 3. This up here is in line with 3. And I need to get in line with negative 1 right here. I need to get in line. So let's count. I'm in line with 3. Pay attention, I'm up here. I'm in line with 3. Let's count. 1, 2, 3, 4. So I'm right at negative 1, negative 4, right? So because I'm running to my left, then it's safe to say that this distance from here to here is negative 4. Now the formula, as we suggest up here, is that gradient is equal to rise over run. So m then is going to be equal to rise, which is negative 4, and the run, which is going to be 9. Oops, sorry, that's incorrect. The rise is 9, pardon me. The rise is 9, and the run is negative 4. So the gradient of this line works out to be negative 9 over 4. I don't know if you feel comfortable in turning it into a decimal. I'm not a big fan of the decimal, so I'm going to keep my answer as negative 9 over 4 for my gradient. All right? And that is how you find the gradient of the line using the graphical method. All right? So that's it. That's how you get that 2 marks right here. Sorry, this alone is 5 marks. All right? Or 4 marks maybe, give or take. So that is how you find the gradient of the line. All right, and again, you can find a breakdown version. Every time that I teach you something, there's a breakdown version for this. It's available on a specific tutorial. It's not a class, it's a tutorial. And I don't think it's maybe like about 50 minutes long, and we cover about 3 topics. So if you need that specific tutorial to get a better understanding of this, feel free to direct message me and tell me the topic so we can move right along. Okay? Next question. Assuming that you guys don't have any questions, or you don't have a do-over, let's move right along.
Sir, you said that CSEC wouldn't provide, they would provide the graph sheet?
Yes,
Or,
graph sheet is
okay, they would. Okay.
yeah. Calculate the length of AB. So this requires a formula, right? You could, if you're on the graph, you can use your ruler and measure it, but I don't think that they're gonna appreciate you using a ruler if it's 2 marks. I'm assuming that if the question is worth 2 points, they're expecting to see you apply the formula. So we're going to need to grab a formula for this. Length of line is equal to the root of y2. That's right, that's a little bit better. Oops. So the formula for the length of a line is going to be y2 minus y1. So it's going to be y2 minus y1 squared plus x2 minus x1 squared. All right, so that's the formula for it. So then you might need to recall what is y2, y1, x2, x1. Where do you get those values? Well, those values, guys, are obtained from up here, from the inception. From the inception, when we got the points, they told us that This is x1. That's y1. This is x2. This is y2. So therefore then, we can plug those numbers into our formula as we have it here. So, according to the formula, it's the square root of y2, which is 7, minus y1, which is negative 2, plus x2. Just pay attention to up here, guys. Those are numbers. Those are where I'm getting the numbers from. X2 is negative 1, minus x1 is 3 squared. Now 7 take away negative 2 is 9. So that's going to be 9 squared plus minus 1 minus 3 is minus 4. So that's minus 4 in bracket squared. Now when you square 9, you will get 81. And when you square negative 4, you're going to get 16. So the appropriate solution for this is root 97 units. So the area of, sorry, not the area, the length of the green line there is root 97 units. If you want to express it in decimal form, that is totally fine as well. All right, but I am quite comfortable and I respect the answer written in root form. Any questions, guys?
No, sir.
Oh, Avi, you're the one that just text in the group and see that. Okay, all right. All right, good. All right, next question, ladies and gentlemen, the coordinates of M. Now, be careful with this one, right? Because there's two M's that you have to consider when it comes to coordinate geometry. You would have already seen that we calculated one of the M's already. That is common M.
Their midpoint.
Correct, very good. So it is the midpoint that we're looking for. All right, so there's two M's, guys, that you have to look out for. You have capital M and you have common M. So in this case, as Ahenia just said, looking for the midpoint. Again, we need a formula for this. Capital M is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. And we already have the values of x1 and y1 and x2 and y2 already because we have already labeled them up there. So in this case, x1 and x2 is 3 and negative 1. So that's going to be equal to 3 plus negative 1 over 2, comma, y1 and y2 is negative 2 and 7. So that's negative 2 plus 7 over 2. All right, now 3 plus negative 1 is positive 2 over 2, comma, negative 2 plus 7 is going to give us 5 over 2. Now 2 over 2 is 1, comma, and if you want to write 5 over 2 as 2.5, that's fine as well. I personally would just write it down as 5 over 2, all right? I am not a big fan of writing down decimals as my answer unless it's completely necessary. So once I see a fraction, I'm going to leave it alone. So if you want to write down 1 comma 5 over 2, or you want to write down 1 comma comma 2.5. All right, so that is how you find the midpoint of the line. All right, so that takes care of that question. The next question we are then asked is to calculate the equation of AB. All right, now, if we can recall that I discussed with you in class that the equation of a line is y equals mx plus c. That's the equation of a line. Where, let me grab my red ink here, where m, that small m, is the gradient, which we already have right here, and c is the y-intercept, which would be the point where the line crosses the y-axis. Now, unfortunately though, the graph that I've drawn on screen here isn't really accurate, and I'm not quite certain if there's someone in here that has drawn the graph. If you have drawn the graph and it's accurate, then you should be able to just write down that the answer is going to be y equal negative 9 over 4. Sorry. Because we already have the values now, because we can see the graph and we have the gradient. So we could say that y is equal to negative 9 over 4 x. And I'm guessing that this is maybe 4.5. So I'm guessing that this is 9 over 2. I'm not sure. All right. By looking at the graph, it looks like it goes through 1, 2, 3, 4. It looks like it goes through 5.5. So it looks like 11 over 2. So I'm not quite certain, right? However, I'm going to do because I'm not certain, I'm going to do my calculation and see if I can verify the answer. Okay. So if you're on the graph, you could just write down the answer. But we're not on the graph and the graph is not accurate. So let's just go ahead and do some calculation. All right. So the thing that I know already is that negative 9 over 4 is the gradient. So I know that this m value right here is going to go right at this position right here. That negative 9 over 4 or 9 over negative 4, same thing. And I know that I can either use this bracket up here. So I can choose to use this bracket up here as my y, or I can use this bracket as my y and x. I'm going to use the first one because the numbers are smaller. So I'm just going to use the first one. So in this case then, I'm going to use the letter y to be 2, negative 2, and the letter x to be 3, and I already have my gradient right here, m, which is 9 over 4. Let's see what happens when we put those numbers in. Y is negative 2 and x is 3. So y is negative 2, and we know that m is negative 9 over 4. And we know that x is going to be times 3. And then we're looking for c. All right?
Sir, I think it was positive 9 over negative 4.
Yeah, man, it's the same thing. The whole fraction is negative, you know.
Okay.
So whether it's negative 9 over 4 or 9 over negative 4, the point is that the whole fraction is negative 9/4.
Okay.
All right, yeah. All right, so in this case now, we need to solve this equation for c. I think currently in algebra, I think maybe the online students, we haven't reached equations as yet. I'm not quite sure if we reached there as yet. I know that last video that I uploaded, we were at algebraic fractions. So I don't think you guys are at equations as yet, but we're going to go ahead and solve it regardless. All right, so for an equation now, we need to get this letter to be by itself. So we need to do some simplification. So we're going to have here negative 2. I'm going to go ahead and multiply the 9 by the 3. So I'm going to end up with negative 27 over 4. Negative 27 over 4 plus c. All right. So negative 9 times 3 is negative 27 over 4. And then now we're going to carry over the negative 24 over here. We're going to put it to the other side because I need the c to be by itself. As you will learn, or as you would have, or you are currently learning, depending on which of my pools you're in, when we're solving an equation for a letter, the ultimate objective is to get the letter to be alone by itself. So at this point in time, the letter C, which is the letter that we're looking for, it's attached to negative 27 over 4. So we can move that negative 27 over 4 to the other side. So by moving it to the other side, we're going to end up with negative 2, positive 27 over 4. And that's going to give me a value for C. All right. Now let's work this out. It's a fraction. I'm going to put it over 1 and find the LCM. Once it's a fraction, you're going to have to find the LCM. All right, so the LCM here is 4. 4 into 4 times it by 1. And sorry, 1 into 4. Oops, I made a mistake, guys. 1 into 4 goes 4 times. I'm going to times this by 4. And 4 into 4 goes 1 times. I'm going to times this by 1. Now, negative 2 times 4 is going to give me negative 8. And 1 times 27 is going to give me 27. And that's equal to C. So therefore then, this is going to be negative 21. No, this is going to be negative 19 over 4. Negative 19 over 4. So when I check this out, it looks like about 4 3/4. All right. If you were to work this out, you're going to get 4.75. Negative 4.75. Sorry, positive 4.75. Somebody can check that 19 over 4 for me and tell me if you get 4.75.
Yes, sir.
4.75. So we got 4.75. So like I was saying to you earlier, guys, because the graph is not drawn accurately, it's not on an accurately drawn graph, the value that you're seeing here isn't fully accurate. But if you were to go ahead and plot this on the graph using the coordinate system, you'll realize that the value that we got for C will go a little bit under the number 5 on the graph. All right, so now that we have C, we can draw our conclusion now. Now we're finished. We can say that therefore, the equation of the line is y equal negative 9 over 4 x plus 19 over 4. And that is it. Okay? That is it. I sort that in, guys. Just give me 2 minutes. I'll be right back. All right, guys, so I'm back. All right. Need to grab a quick little 2-minute break. All right, good. So, any questions on that? All right, so we would have completed then how to find the equation of AB. Now, this last one here, I'm sure I can confirm that I did not teach this, right? Because I was depending on you guys to kind of check it out. But I'm going to quickly run through it, right? We don't want to leave it standing. It says determine the equation of the perpendicular bisector, all right? Perpendicular bisector. Now, there are two words here that we need to look at, right? Two words, and those two words are perpendicular and bisector. Now, the word, when it comes to coordinate geometry, just to cut the working out short, when you think about the word, when you see the word perpendicular, what that means, right? Let me just go down here. When you hear the word perpendicular, and we're dealing with the topic of coordinate geometry, when you hear the word perpendicular, you are going to be, all right, so let's see now. The word perpendicular is related to where you're going to take the gradient. So you're going to take the gradient of M1, right? We know that the gradient of the first line was 9 over negative 4, or the same thing as negative 9/4, right? So when you hear the word perpendicular, here's what you're going to do, right? In another class, I will explain the details of why I'm doing what I'm doing. But for now, because you're just trying to work out the problem, if we calculate the gradient of a first line, and the question says something about perpendicular. The shortcut is this. You're going to take the gradient of the line that you currently have, and you're going to turn it upside down and change the sign. So the perpendicular gradient is going to be equal to, which is M2, is going to be equal to, turn the 9 over 4 upside down, you're going to get 4 over 9. And because it was negative, when you flip it and change the sign, it's going to become positive. So that's the rule, that's the shortcut, right? Where did my information go? Don't know where my information went, guys. Whoops. Okay, let's just write that again. I don't know where that information went. All right, so then, if I say that M1 is equal to negative 9 over 4, then I know that M2 is going to be equal to 4 divided by 9, and I change the sign. That's the rule. So this is the original gradient, and this now is going to be called the perpendicular gradient. All right, so we turn the gradient upside down and we change the sign from what it is to what it was to the opposite. All right, so if it was positive, when you flip it, it would become negative. That's the first thing that we need to look at when it comes to this last question up here that says perpendicular bisector. Now, the next word that we need to understand is the word bisector. And whenever something is bisected, it means that that thing has been divided into two. And when you divide something into two parts or two equal parts, you slice it right in the center. And when it comes to coordinate geometry, when we use the word center, we replace the word center with midpoint. So therefore, in this case, the perpendicular bisector or the bisector of this line here is going to be the midpoint that we had calculated earlier. Where is it? There it is, 1, 2.5. So this would be your bisector point. This would be your bisector point. So we already have the perpendicular what? Gradient, right? So that's M2. And now we have the bisecting point, the bisector point. So the bisector point in this case is going to be equal to 1, comma 2.5. If you want to use 1, comma 5 over 2, that's up to you. I'm just using the decimal since it's very straightforward. So now I have two things that I need now. I have my perpendicular gradient and I have my bisecting point. I can go ahead and say y is equal to mx plus c. Now in this case, my bisecting point is going to be x and y. So in this case, y is going to be 2.5. M is going to be the flip, the 4 over 9, times x, which in this case is 1. And then I'm going to add c to this, plus c. So remember, it's a new line now, guys. So I know that probably 1, 2, maybe none of you, maybe all of you are saying, then sir, didn't you find c over here already as 19 over 4? That's the c that matches with the line AB. I'm not looking for the c value of AB. I'm looking for the c value of the perpendicular bisector. So that's a different c value. All right, so we're going to go ahead then and we are going to go ahead. So go ahead for me now, guys, and we're going to say 2.5 is equal to 4 times 1 is 4 over 9 plus c. What's 4 over 9, guys, on the calculator? Maybe it's a recurring decimal, I'm not sure.
Yes, sir. 0.444.
0.4.
Flat or 44444?
4444.
Yes, it's a recurring decimal. So I'm going to use two of them. So 2.5 equals 0.44444 recurring plus c. All right, so now simply we're going to bring this over here. It's going to be 2.5 minus 0.44 equals c. What is 2.5 minus 0.44?
2.06.
2.06. All right. If you want to call it 216 over 100. Yeah, 2.06 is fine. So therefore, then my equation then of my perpendicular bisector is equal to y equal 4 over 9 x plus 2.06. All right, and that's my answer. Again, you can get a full breakdown, step-by-step, detailed explanation of this in part 3 of my coordinate geometry series that is currently available in the playlist that was sent in the group. All right, you can just go in there and look for part 3. You'll find it. It will break down the whole concept of perpendicular bisection for you. Okay, so that takes care of that full-blown question there. All right.
Sir, let me
yes, go ahead.
backtrack a little bit. The bisector where you said that make it that
the
bisector point. Yes.
The bisector point, the word bisector means middle. And middle in coordinate geometry means midpoint.
Okay.
So I got the 1, 2.5 from the previous calculation that I did.
Yes.
Yeah.
Okay. Yes.
And perpendicular gradient means I'm going to take the original gradient that I had calculated earlier, flip it, and change the sign. All right, so that takes care of that. All right, moving right along then, I'm going to move to question 5. All right, I'm going to move to question 5. All right, so if you don't mind, you can go ahead and screenshot what you need. If you have taken it off already, go ahead and screenshot that. You can screenshot it like this, and then when you screenshot it, you can zoom it up when you're writing stuff off. So I can get some space to work on. All right, assume that we have... All right, good. Here we go. Now, we're going to be looking at this next question here, which is a volume question. Again, I know that for my online students, you guys are currently at sector, segment, and arc. And I think I started introducing you to volume. So this is not going to be unfamiliar for my students in the physical class. I think you guys would have seen this. So this is not an unfamiliar territory for any of you. All right. Now, number 5 says the cylindrical tank has a radius of 0.7 meters and a height of 2.5 meters. Your 3 task is to calculate the volume of the tank. If the tank is filled with water to 3/5 of its capacity, we need to then calculate the water that's in the tank, the height of the water in the tank. And then the next part is that we're supposed to calculate the surface area of the tank. So let's attack this. First thing I need to do, guys, is to have an image of what this tank looks like. And since we're told that the tank is cylindrical, then it's safe to say that the tank perhaps looks like this. That's my cylindrical tank, all right? And then from here in the center, from here in the center to here, that's my radius, right? So I'm thinking that everybody here would have seen me draw this diagram in our regular tutorial classes, right? So that's my radius. So we're told that the height of this tank here, we're told that the height is 2.5. So let's put that measurement on. 2.5 meters. And we're told that the radius is what? 0.7 meters. No, that's all they gave us. They only told us that the radius is 0.7 and the height is 2.5. Now we have to calculate the volume of the tank. So can we recall that volume is equal to A multiplied by H, which we would have already discussed that A stands for the area of the cross section. Where's the cross section? The cross section is the part of the prism that is identical. So in this case here, the cross section of this cylindrical container is a circle. It has a circular base. So that's the cross section. So in this case then, volume is going to be equal to A, which is the area of the cross section, which in this case it's a circle. And so the area of a circle is going to be equal to pi r squared. And then now we're going to times it by the height of the cylinder. So we know the pi value is 3.14. And we are told that the radius is 0.7. So that's 0.7 squared. And we're going to times that by the height, which is 2.5. So go ahead and process that calculation for me, please. 3.14 multiplied by 0.7 multiplied by 0.7 multiplied by 2.5.
Sir, I got 3.85 meters cubed.
3.85 meters cube. And
I get 5.4.
All right, no problem. You can now it's going to calculator right here now. No problem. So all right. So what were the numbers now?
3.4.
So the numbers were 3.14 times 0.7 times 0.7 times 2.5. 3.85.
Yeah.
All right, so that is going to be the volume of water or volume of stuff that can hold in that particular tank. All right, so that's it. That's it. No more than that. And don't think me I try tricking you guys. I'm telling you, when you go on a CXC paper, this is how the questions are set. In fact, I didn't even write these questions. If I wrote this question, it would have been much harder than this. when CSEC writes the question, they're writing them in stages. So when I tell you that what we're doing on screen right now is exactly how a lot of the questions in exams are done. This is how CSEC breaks them down, right? Because I asked AI to model a particular exam paper, and they gave me these. They're the one that gave me these questions, right? And they built a question from a random paper picked from the CSEC past paper bank. So this is how it's structured. Next one. Now, here's a little intuitive question. If the tank is filled with water to 3/5 of its capacity, your task is to calculate the height of the water. Now, is that part here? I have a confession, and me add on this here. What they asked us was, what is the amount of water that's in the tank? I felt like the calculation was too simple, so I added on this part right here just to add a little twist to it. All right? So it says, if the tank is filled with water to 3/5 of its capacity. Let me explain what that 3/5 means, guys. This 3/5 means that the tank is divided into 5 equal portions. 1, 2, 3, 4, and 5. So if the tank is filled to 1/5, it would be about here. Hold on, give me a sec. Something is not right. Okay, hold on. I think I need to refresh my page. So if the tank is filled to 3/5 of its capacity, it's almost full. It's almost full. So what that means then, right, if I'm to interpret this correctly, the tank is filled to about here. So basically, some whole heap of water in the tank now. And it's filled 3/5 up. So this is 1, this is 2/5, this is 3/5, this is 4/5. And 5 out of 5 means that the tank is full to the brim. So basically, the tank is filled to 3/5 of its capacity. That means now, if I wanted to know how much water is in the tank, all I have to do is find 3/5 of the amount of water that can hold in the tank. Now, from the previous question, we were told that the tank has a complete capacity of 3.85. So now I can say that the volume, what I can say now is that the volume of water currently in the tank is going to be 3/5 times 3.85, because the complete tank can hold 3.85, and the amount of water that is in it right now reaches about 3/5 of the height. So go ahead and calculate for me what is 3/5, or 3 divided by 5 times 3.85.
So I'm getting
2.31.
2.31. Yeah.
Pardon me, how much I got?
2.31.
2.31. So therefore, the amount of water that is currently in the tank right now is 2.31 cubic centimeters. Now remember, that's the part that the AI wrote, So I felt like that was just too easy. In my opinion, I felt like the way how I teach my students, that question was too easy. So what I did now was just add on this part now that says we should what? Calculate how tall or what's the height of the water in the tank. So to do that now, we're going to go ahead and write down volume is equal to area times height. And at the moment, we are not interested in the volume of the tank. We are interested in the volume of the water. So based on the previous calculation, the volume of water in the tank right now is 2.31. And we already know that the base is going to be the base is circular, so that's 3.14, and the radius is 0.7 squared. Because remember that we established that from up here. And then now the height now isn't the height of the tank. We are interested in finding the height of the water. So therefore, h is unknown. All right, so go ahead then and multiply 3.14 times 0.7 times 0.7, please. (3.14) times 0.7 times 0.7.
1.54.
1.54. 1.54 times the height. All right, what's the opposite of multiply?
Divide.
So we're going to divide by 1.54 to get the height of the water. And it has to make sense. The answer you're going to get has to be less than 2.5. Waiting, guys, waiting for the answer.
1.5.
1.5, so that means the height of this here is 1.5 meters. All right. So basically then, the tank, the water that is in the tank has reached a height of 1.5 meters. Okay, and that's it. That's how you record that question. So these are the questions that you're seeing here now, guys. These are the questions that come on exam, right? These are the exam questions, and it can get a little bit more challenging, but we're not thinking about it. We're dealing with the problem as we face them, right?
Excuse me, sir. I calculated it a different way.
And you got the same answer?
Yes, sir.
Wonderful. Yeah, man. Because as long as you get the same answer, it is mathematically acceptable.
Okay, sir. So I would still get the full marks for that
Yeah,
part
of course.
there.
Of course. Full marks. There's not a one way to work out the problems. All right, so that takes care of that. Next one says calculate the total surface area of the tank. Now, again, I don't think my online students I think that's what we're going to this week, total surface area. I think that's where we're going to this week. So there's a formula for total surface area. Total surface area is going to be equal to the perimeter of the base times the height multiplied by 2 times the area of the base. That's the formula. In the class, I'll explain to you how this formula was derived. But for now, work with me, guys. Total surface area is equal to perimeter of the base, that's the distance around the base, times the height of the tank, multiplied by 2 times the area of the base. So again, it's the perimeter of the base, that's around the edge of the base, multiplied by the height of the tank, plus 2 times the area of the base. So total surface area, let me just zoom up here. Total surface area is equal to, now because, ladies and gentlemen, the base is circular and we want to go around the circle, we know that that's going to be circumference. And circumference is 2 pi r. And we want the height of the tank, which we already have, plus we know that the base is circular, so it's going to be 2 multiplied by pi r squared. So we have a formula for it there. So it's 2 pi r h plus 2 pi r squared. All right, so it's going to be 2 times all right, so it's going to be here. Let's zoom up here. All right, good. Here we go. It's going to be 2 times 3.14 times the radius is 0.7 times the height is 2.5 That's in a bracket. So 2 times pi times the radius times the height. And then we're going to add now 2 times pi r squared. 3.14, that's pi again, times the radius squared. So that's going to be 0.7 squared. We're going to work out the first part. What is 2.314 times 0.7 times 2.5? Let's do that part first. Waiting, guys, waiting.
Here I got 10.99, but I'm checking again because it doesn't seem correct.
Can somebody help her and confirm?
Sir, I got 14.07 meters squared.
I got 10.99.
All right, so what were the numbers? 2 times 3.14 times 0.7
times 2.5.
times 2.5. 10.99. So Zahina, check that again.
Okay, sir.
All right. And then now we're going to add that now to what is 2 times 3.14 times 0.7 squared.
I'm getting 3.08.
Can somebody confirm that?
Sir, it's correct.
All right, and when you add those together, confirm if you got 14.07. Confirm?
I'm getting 17.
17, 10.99 plus 3.08. Too far.
Sir, 14.07 is the answer.
Okay. All right, and that is it for that question. Okay, and that's it. That's how you work on that question. All right. Now, for question 4, I haven't taught that topic as yet, so it would be pointless in trying to pressure you guys to like learn something. That's not how I go to work. So we can leave this
Sir,
on
can
our
you slide the board up a little, please?
Sure. All right. So for question number 4, it's no point in going through that because I haven't taught that topic to any of my online students. Online students are face-to-face. So we can leave that until when we get to that stage. We can actually use this as an example when we're in our class. All right. And then now, as you can see here for number 3, that's a worded problem. I'm going to leave you with that one to do because, we're not going to spend too much long. What I want to emphasize, guys, is you see these practice sessions is not a case where I want to charge you for them. I would do them for free. But I want you guys to get into the habit of taking up a worksheet, When I send you the worksheet, you take an hour and a half, and that's all that you do. You don't need to practice maths for 3 hours. You just need to take the worksheet, get a couple questions that are not in your book, right? Because when you practice what I do in class, all you're doing is that you're regurgitating. That's all you're doing. You're not getting any experience. The experience comes from unfamiliarity, right? You have to not see the question in class. You have to be able to look at a question that comes from a random worksheet somewhere off the internet, and then you use the notes that I give you in class as a form of reference or a form of guide towards answering the question. Now, for the online students, right, you are going to this topic this week, factorization, right? And you haven't gotten to that topic as yet, which is equation. But you have completed this. This was what you did last week, right? And you also did this the first class you did in algebra. So you guys can take on that, right? And then now we know, say, everybody in here is supposed to can handle fractions. Everybody in here can do what? Everybody in here can use and calculate and work out the decimal. These two might be a little bit unfamiliar, right? Because it's been a while that we haven't done stuff like that. So what I'm going to do, I'm going to put a tick on the ones that I think that I know you guys can do. So I know that if I leave you alone, you can do that one and that one. These might be a little tricky, but you might be able to figure them out. This one was what we did last week. Distributive law. This one was also done. How to, when you multiply and you add the powers, when you're dividing and subtract the powers. This one is substitution. This one is going to be done this week. And also, we're going to be doing that one in weeks to come. And then we have the worded problems down here, which, as I said, we have a complete tutorial on this. That is higher purchase. You guys can take on that as well. And you guys can also try that one as well. All right? So I'm going to leave you with the practice sheet to do. I'm only here to guide you and help you and do a couple of the tough ones then for you. Right? And you can take them on. And again, for question 4, we haven't done that at all. So there's no point in forced learning or forcing you to see something that you have not yet been taught. Okay? And that's it. So this is what a practice session is like, guys. No more than that. 1.5 hours, 2 times per week outside of your regular class. And this is how you gradually build up yourself. But you can only do it, ladies and gentlemen, by doing unfamiliar questions. You can't do the same questions we do in class and call that practice. That isn't practice, that's regurgitating. Okay? All right, so you can shoot your shots at these. Let me know if you have any challenge or you're trying them. My phone is always open. Reach out, send me your solutions, and I'll let you know if you're on the right track. All right? But until then, I'll see you guys tomorrow at 7. We're going to pick up from where we left off, and also from our face-to-face class. I'll see you all tomorrow at 4 o'clock. Okay? Any questions?
Yes, sir, you're going to send these question sheets to the...
Oh, you want the question sheets?
Yes.
Okay, no problem. I'll send it in the group.
Yes, sir.
All right. No, I'll send it to you individually. So please message me and ask me for the worksheet.
Yes.
Because it's unfair for you to...
Yes, sir, because we don't get any worksheets.
You haven't gotten any?
No.
Oh, wow. Okay. I have quite a few, I have quite a few. I just don't know how I've uploaded them. But I'm going to upload some worksheets for you. Okay?
Yes, sir. I appreciate it.
All right. No problem. You all take care now. Have a good evening. Be blessed.
Thank you, sir.
Same to you.